back in depth with. I'm Richard Price, CEO of academia.edu, and I am always super excited to enter fascinating piece of academic research with all you. A quick reminder before we dive into things. The goal here is to present the research in as a way as possible. I'm not promoting or endorsing these findings, just giving you access to out there. Because, academic work is about exploring ideas, not handing you the ultimate truth. Alright, so today we'll be discussing the paper, The Architecture of Trust, a critical evaluation of the secure software lifecycle, authored P. Bellisan, published in 2023, quite recent. And if you've ever wondered why software seems so complicated, or why massive security breaches happening advances in tech, this episode is going to energizing and maybe little alarming in good way. Let's get into the main question of Bellisan's paper. Basically, the paper asks, how is the secure software development lifecycle, or Ssdlc, in really truly creating trust and security in the code that powers, pretty much our civilization? Why does this matter? And is it enough to just add security patches? The end of software projects, should security be into every single phase from start to finish? Now, before we get to findings, let's picture what's at stake here. Think about it. Rely on code, everything, from heart monitors to your banking app, from voting systems to the game you play your phone. Of it is together by fragile lines of code. A single mistake can threaten of people and cost billions. The core of Bellisan's argument is that old way, you tack security onto a nearly finished software project, isn't just inefficient, it's catastrophic. So how did we get here? Bellisan traces the evolution of software security practices, starting with the waterfall model, where security was basically an afterthought, and moving toward agile and now DevSecOps. The shift here is called shifting left, meaning bring security work into very earliest phases of development, not just at the end. That's supposed to reduce risk and cost and create genuinely safer systems, at least in theory, and the a stop at history dives deep into technical strategies like threat modeling. Ever heard of Stride? That's a framework for spotting all of threats, from spoofing to denial of service. There's also PASTA, which actually gets into potential attack simulations and business impacts. Think of as roleplay, except it's, deadly serious. But okay, maybe my favourite part. Bellisan spends some serious time breaking down symbolic execution, which is a method mathematically proving software correctness. It's like, if testing is poking the code and seeing what happens, symbolic execution is building a giant math of every possible path that could take. It's incredibly powerful finding hidden bugs. Of course, Issa notes the path explosion, drawback, meaning as code complexity grows, the number possible paths can get unmanageable. Really, a silver bullet? Oh, and learning. Bellisan also talks about companies are using AI to detect vulnerabilities. By training neural networks on huge libraries of buggy code, these models can flag new loopholes even the best human might miss. But, does that mean humans can slack off? Not so fast research points to a weird effect called Overbias, where developers using assistants upwriting less secure code, mistakenly, it's safer. Yikes. Now's where things get a little philosophical. Bellisan argues that software security is never just technical. The human element is massive organizational culture, incentives, even plain old mistakes. These are what sink most cybersecurity efforts. There's a whole model called OCCM that shows, for example, that if your boss doesn't care about security, no checklist will save you. Over 70 of data breaches come down to human error, not technical failure. I mean, isn't that wild? Can build the fanciest defenses then. Poof, somebody clicks a phishing link. Oh, while I'm thinking about it, once I broke a coffee machine just by plugging it into the wrong outlet. I guess that's not really related, except, humans make silly mistakes everywhere, including software. Back to the paper. Bellisan compares different industry frameworks for measuring software security, SAM, which gives a how-to for building maturity, and BSIM, which lets you benchmark against what top performing are actually doing. There's no one-size-fits-all answer, and again, reminder, these standards reflect best practices now, but not eternal rules. So what does mean for you? Well, if you're building software, using services, or even just existing in a world run by code, it's important to realize security is a shared responsibility, never a finished job. Do you trust the tools, the teams, and the processes behind what you use? If Bellisan's research, that's a healthy skepticism. Wrapping up, academic research like Bellisan's isn't doctrine, it's a lens, perspective. The science of software security evolving as fast as the threats we face. So stay curious, question what's under hood, and appreciate that both in code and in organizations is something we all play a part in building and preserving. Thanks for In Depth with Academia. Take care, and hey, go check your app permissions just in case. See you next time.